So we're starting lesson 3. This is layers of the atmosphere. And before we start getting into the specific layers, we're going to watch a quick video on two things. One person is going to be climbing a tall tower, and the other person is going to be starting near the top of the atmosphere and jumping down. So here's a person that's climbing up a 1,600-foot tower. This tower it's just crazy. It goes about a half mile up into the sky, and we've been climbing here they've been moving for a long time. Once they get to the top of the pole at the top of the tower, they start climbing this. So as this person is climbing up, you can just see how high they are up in the atmosphere. And what we're about to learn in this lesson is that this is just the very bottom. So this person's about a half mile up. These roads look tiny. They're going up, 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 up. There is a link to this video you can find somewhere near on my website. I think it says links to videos from beginning of class. But anyway, we're going to move on. So this person is in a capsule that's headed in a balloon that's going up to the highest parts of the atmosphere, and this person is going to jump out and skydive back down to Earth. Okay? There is gravity up as you get up into space there, and he's pretty much going to get as close to space as you can. So you'll see he's wearing a spacesuit once he finally gets high enough in the air. So what you can see here is, this is the Earth, and you can basically see the layers of the atmosphere. He's obviously still in the atmosphere since there's a balloon pulling him up, but that balloon is, about as high as it'll go at this point. They're 38 miles up. He's wearing a spacesuit, so there's very little air, and it's pretty amazing what ends up happening. Okay, so as we start our notes, we're actually going to start at the very bottom of the page, okay? So if you take a look at the very bottom of your notes, we end up right down here at this very first layer. And the first thing you need to know is that all weather happens here, okay? This first layer, and we don't even know the name yet, this first layer contains all weather. Everything that we experience here, it's in this first layer, as well as 75% of all air is down here. Okay, we have a lot of air. If you remember from the pressure and temperature notes, it's all piled up down around us. We got a lot of air pressure right here, and 75% of all air is in this first layer. Okay, there's really only three things I want you to know, and the third thing is that this first layer, which is called the troposphere, also contains the jet stream. So the jet stream is at the very top of the troposphere. So this jet stream, let's take a look at it. The jet stream circles the very top of the Earth. Here's the North Pole. The jet stream goes around the the northern latitudes. The jet stream is really near us a lot of the time. Sometimes it's above us in Canada, sometimes it swings below us, but a lot of the time the jet stream is in our area. Okay, and so the jet stream is what's going to drive a lot of weather. We'll see that in the next section. But what I want you to know is that the jet stream is at the top of the troposphere. So the next layer above the troposphere is called the stratosphere. Okay. The troposphere has three details that I want you to know about it. The rest of these only have one. Inside the stratosphere, air is getting really thin. From the picture here, you can see that there's weather balloons make it up here. Sometimes planes make it up into the stratosphere. But towards the top of the stratosphere is what's called the ozone layer, which you may have heard of. It's really important, and I think the next lesson, or maybe 2 lessons from now, we're going to talk about the ozone layer and what it is doing to keep us safe. So that's the stratosphere. The stratosphere Towards the top of the stratosphere, you end up with the ozone layer. Okay? Moving up the atmosphere is the mesosphere. Okay? And in the mesosphere, that's where you see shooting stars and meteors burn up in the mesosphere. Every movie you've ever seen where something is re-entering the atmosphere, it's the mesosphere that is so dangerous that things are burning up inside of it. All right, lastly is this really big one. This really big one up here, this is the thermosphere. Okay. Now the thermosphere breaks into two different ones, so I want you to write this such that it shows you that, okay, these two make up the thermosphere. The bottom half of the thermosphere is called the ionosphere, and this is where auroras happen. So here's an aurora. This is the International Space Station you're seeing. There's a solar panel. But these are the auroras going on in the ionosphere. It's really kind of cool. These are also circling the top of the Earth and the bottom of the Earth. So they're easier to see if you're in Alaska. They're easier to see if you're up north. Here's a different view of the auroras. So you can see the Earth turning around them as they're orbiting around the Earth. The auroras end up in the ionosphere up here. And then the last layer we need to know, this very top part, is called the exosphere. This is where satellites orbit. There's very, very few molecules, very few anything going on. The picture right here, this is the International Space Station. We'll talk about it more when we get to the space section, but all we'll say today is that it is very, 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 very cool. So that's the exosphere. All right, those two make up the thermosphere. Okay, so on to the next page. We have temperature graph to do, and we have some other electromagnetic stuff to talk about. First, we're going to talk about the temperature graph, but we're going to start from the bottom again. Down at the very, very bottom, the bottom layers look like this. We have the troposphere. As you go up a mountain, as you go up into a plane, you'll find that as you go up in the troposphere, it's getting colder and colder and colder and colder. Okay? So it doesn't start out very hot. It's not very hot on the surface. It doesn't get very cold. It just goes, it gets colder. But then, once you get to a certain height, and this is how we know we're at the top of the troposphere, the temperature stops going down. The temperature stabilizes, and then, as soon as we start getting into that ozone layer, we start increasing in temperature. The temperature increases because the ozone layer is absorbing some light, basically, and it gets pretty hot. It gets hot right at the prime time of the ozone layer. But then the ozone layer kind of ends, and it cools off. The coldest part is at the very top of the mesosphere. So it goes from very hot at the top of the stratosphere to very cold at the top of the mesosphere. Now here's the thing people are surprised by. People get surprised because after the mesosphere, when you get into the thermosphere, the word thermo means temperature, means heat, because the thermosphere is just getting hotter and hotter and hotter and hottest. So these molecules at the top of the thermosphere are moving very, 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 very fast. They're super hot. The thing is there are very few of them. They're very spread out, so they're far apart. They might be moving insanely fast, so they're technically hot, but they're so far apart you don't feel hot when you're there. You feel cold because you're not really getting hit by very much at all. That's the temperature side of the graph. The thermosphere is just hotter and hotter and hotter. Now on the other side, this is actually really simple. You'll be surprised. Okay, we've got radiation from the sun coming, and I've got a little signpost. I didn't want to draw the sun because it would be way too close. So I've got a sign here. It says, to the sun, it's 93 million miles or 150 million kilometers. Now, from the sun, we have all of these wavelengths of light. But the thing is they don't all make it to the ground. So, what I want us to do is just draw arrows to how far these make it into our atmosphere. Now, radio waves, these are the lowest energy. They go through walls. They go through lots of stuff. Radio waves actually make it. And that arrow is going all the way down to the Earth. Boom. Because radio waves make it all the way here. So we can see the radio waves from the sun. We can see them from other galaxies, all that, right here on the surface. Microwaves, on the other hand, don't make it all the way down. Microwaves make it through the thermosphere. Microwaves go through the mesosphere and are blocked in the stratosphere. So as neatly as you can in your notes, try to show that microwaves only make it down to the stratosphere. Infrared light. For the most part, is blocked in the stratosphere. You know, some of it makes it to us. A lot of it's blocked. What do you guys think about visible light? Does the visible light from the sun make it to the surface of the Earth? Think about it for just a minute. Of course it does. Can we see it? So visible light, that would be this arrow right here. Visible light makes it all the way down. Okay? Now, none of these things are harmful to us. We can take radio waves all day. Microwaves make you feel kind of warm. Infrared waves make you feel toasty. Visible light is what we see. Now, ultraviolet light, this is the stuff that causes sunburn. This is the stuff that's really, really harmful. And you might be surprised, but most of this ultraviolet light is blocked right here in the stratosphere by the ozone layer. Some of it does make it down to the ground, but most of it ends right there. Do the X-rays from the sun make it to the surface? I'm really glad it doesn't, because X-rays are blocked up here in the thermosphere. Same with gamma rays. They make it a little further, but they don't really make it from the sun. If X-rays and gamma rays could make it to the surface would be unlivable. Same with ultraviolet rays. So it's really fortunate that this chart works out the way it is, because this makes it a world we can live in. And that should fill in that last bit of notes on this page.